Most mixers use saturation to make their tracks warmer and fuller, but like salt in cooking, a pinch can transform a dish and too much can ruin it. Today I'm going to show you how to use saturation so it enhances your mix instead of destroying it, by understanding what's really going on. We'll talk about the different flavours saturation adds, the hidden pitfalls of using it and how to avoid them, while still getting all the benefits. If you're new here, I'm Sara Carter, a BBC trained sound engineer and professional mix engineer, and I help home studio musicians mix with more clarity so you can get professional results faster with more confidence, without doubting every move. Before we can control saturation, we need to understand what it's actually doing to your audio. Saturation is a subtle form of distortion that, through gentle soft clipping, enriches the sound but keeps its original character largely intact, unlike distortion that is much more extreme. Saturation adds harmonics, and a harmonic is a frequency that is an integer multiple of the fundamental note or tone that is extra to the original signal, and it occurs at higher frequencies. The two types of harmonics generated are odd and even. Odd harmonics, which are the third, the fifth and the seventh multiple of the fundamental, can make a sound brighter or more aggressive and punchy, and that's great for cutting through a dense mix. Even harmonics, which is the second, the fourth and the sixth multiple, combine more musically, giving warmth and fullness because they align well with the musical scale and octaves. So they just sound right. Odd harmonics sound a bit odd. Here I've got a tone generator giving us a 200 Hz tone, and you can see it here represented in the spectrum analyzer. So what happens when we start to add saturation and the different types of harmonics to this signal? What does that look like? If we take the Schoeps omnichannel and if we look at the saturation section, it gives us odd, even, heavy and crush. We're just going to look at odd and even for this example. So if I activate that, you see these extra harmonics appear in the spectrum analyzer. So the original tone or note is 200 Hz and odd harmonics representing thirds, fifths and seventh harmonics and continuing. We see that for 200 Hz we are getting a 600 Hz tone because 200 times third order, so 2 times 3 is 6, and then fifth, 2 times 5 is 10, so 1 kilohertz there, a harmonic, and then seventh on a 200 Hz tone, 2 times 7, 14. Okay, and on it goes. So those are the odd harmonics that are added to an original tone, in this case 200 Hz. What about even then? So here we have second order harmonics. We see 400 Hz tone being reproduced or being added, and then fourth order is 800 Hz, and then lastly we're getting one here at 12, which is our sixth multiple. So I hope that makes sense mathematically speaking. So how do these actually sound? Odd harmonics have a brighter, edgier tone to them, and even harmonics have got more warmth and fullness. So let's listen to a couple of audio examples of that. Here we've got a bass guitar. Quite soft and round sounding. Let's see what saturation does to change the tone of this bass. Let's start with odd. So these are our edgier, more gritty sounding harmonics. See if we can detect that actually within a bass guitar, which is predominantly low frequencies, lows and mids. Let's see what this sounds like. So you can hear it's adding a brightness, adding that edge and focus, pointed frequencies sometimes I call them, where it's just making the articulation and the notes of the bass just be a little bit more detectable. What about even harmonics then? These are the warmer, fuller sounding harmonics. I'll bypass that, switch to even. Let's audition this. Okay, definitely add in fullness. What's happening as well, because of that extra content that's being added through the harmonics, it's also increasing the level, perceived level. So let me just pull this down a couple of dBs, see if I can level match that. Okay, just a bit closer for your ability to be able to compare the two. So let's go between the two styles then. So let's start with odd. And then even. Okay, odd sounds a little bit quieter now because it doesn't have that second harmonic. Everything starts at the third harmonic. So let me just do a quick A/B test here for you without me speaking. Start with odd and then I'll flick to even. Okay, so that's the difference that odd and even harmonics can make to a typical bass guitar recording. So you'd listen to your track and decide what it needs, what it's lacking, and how it can be enhanced, and then go from there. So for that particular bass, I think I'd go with adding some more even harmonics to fill it out, make it feel thicker and warmer. The decapitator is a very popular plugin to apply to a drum bus or to individual drum tracks. It's got 5 different styles of saturation. A is modelled after an Ampex tape preamp section and is a tube coloration. E is the EMI TG channel, sound of that particular channel strip, and it's combined, it's got a good low end and a nice crisp high end. N is a Neve console input. Neve we associate with being warmer sounding. However, the sound of this is based around the transistors involved in that circuit. I think it's the 1057 Neve input section. So this Neve is all about transistors, and the distortion from transistors can be perceived as being more aggressive than tube. They produce generally more odd order harmonics. T and P are modelled after different sections of the thermionic culture vulture saturation unit. T is the triode setting and P is the pentode setting. Triode tubes tend to have a smoother quality to them, and P, the pentode, tends to be more edgy, slightly more forward sounding. So let's listen to this on drums. I'll start with A. I'm keeping the drive down 0 at the moment. Bypass it. Let's take it to 2 actually, the drive to 2. I've got the auto set, the output set to auto, but you will hear level changes across this demonstration. So that just demonstrates the range of coloration that you can get from these different audio components that you find in circuits all over audio engineering and audio devices. Tubes don't necessarily always have to be warm sounding. They can have an element of bite to them as well. So the range of flavours you can get from saturation is never ending really. But knowing these different tonal qualities help you decide which one is the right one for the job in hand. So how can you decide which plugin to use? Next time you consider saturation, ask yourself, does this part need more bite? If so, reach for third order or odd harmonic saturation, like a transformer or tape. Does it need more warmth? Go for saturation that's got more even harmonics, like tubes or tape again. Always listen first and choose intentionally. When you know this stuff, it now makes sense why you see the pros using tape on drums or on the mix bus all the time, or tubes on guitars and vocals. It just clicks. I should point out here though, that it's not always that cut and dried, because some saturation components are variable in the types of harmonics they can produce. And it's more accurate to say that a component tends to be or typically creates odd or even harmonics. So I don't want to get fired in the comments for not being precise enough about that. So in the end, I'm afraid you still have to use your ears to judge. Commonly, tubes are mostly warm. Transistors and transformers generally produce more third order or odd harmonics, resulting in more mid and high frequencies. And tape, that can be both. Now, these components rarely operate in isolation in the real world. They're usually part of a circuit where both odd and even harmonics end up combining to create a device's own unique sonic characteristics. So bear that in mind. Imagine a guitar amp. You can play quietly and get a touch of grit, or you can crank it up and the tone completely changes. And it's the same with saturation. The more signal you push in, the more and different harmonics you'll get. I've got True Iron here, which is a transformer modelling plugin. Transformers tend to emphasise low and mid frequencies in a signal, thickening up the sound, but that coloration can change depending on the input signal, as well as the level of saturation. So if I were to increase the input to this transformer, you can see on the analyzer, if you have a look at this frequency here at 600 Hertz, which is the third order harmonic, is getting louder, okay? I'll bring that back down again so you can see that changing, okay? So it's not linear. It changes depending on input level and the amplitude of the signal coming in as well. And then increasing the actual strength of that in this plugin, it actually says there, it tends to lean more towards the non-linearity within the transformer. And this changes depending on the type of transformer that has been modelled. So in this instance, the 111C is the Western Digital, which is very popular. But if we change that shape, that you can see, if you look at the harmonics that are being generated there, how they change when we go to, say, the 108X. Okay? And what we're seeing is a combination of second and third order harmonics combining here on a transformer circuit. I'll use this True Iron plugin on my drum bus, in actual fact my drum and bass bus. I like transformers on the drums and bass because you get that blend of odd and even harmonics, so you get the grit and the edge and aggressiveness, but you also get the warmth, which is perfect for drums and bass. This is the setting that I typically start with. I'm driving more input so that I can exaggerate the effect of the transformer. And what I do is just pull back the output to roughly level match the difference between that extra drive and the output. Let's listen to these drums. I'll bypass this and then I'll bring it in. Now, this is not going to be night and day. I'm showing you a true representation of how I'm using it in sessions at the moment. So anyway, let's have a listen and see what we hear. Okay, so it's quite subtle, but you did hear the thickness coming in on the kick drum and a little bit more snap on the snare. Let me blend a little bit more of it into the mix. Let's go up to 100%, shall we? And let's try it again for you. Nice way to enhance drums using this on the drum bus. So the more you drive input into a saturation plugin, the more the character and combination of the harmonics will change. So it's important to be mindful of that when gain staging your mix. Once you've set your gains, if you feel as though you need to go back and reset them, just be mindful of how the character of the saturation may change if you find yourself in the situation where you need to reduce your gains. So how much input gain should you use? For me, I would suggest if you're looking at a meter in this sort of plugin, if it has one, if it's really pinned, then I would tend to dial it back. And if the needle is hardly moving, then I'd tend to just push it a little bit, push the input in a little bit more, just to get the needle doing something. Then you want to A/B test in context, not in solo. The way that a saturated signal interacts with the other elements in a mix can change from solo to the mix context, so it's really important that you do that. And then push it harder if you want more of a pronounced effect. But stop if transients collapse or the sound gets fluffy or cloudy around the edges. So that's what you need to listen to. It's the transient of the signal and the character of the signal. Now, pushing a signal harder can be exciting, but in the digital world, it includes a problem you can't really ignore. Because saturation adds upper frequency content to your sound, if some of these harmonics are above half your sample rate, called the Nyquist frequency, the digital system can't capture them faithfully. So if your session is using a sample rate of 44.1 kilohertz, the Nyquist frequency is half that, which is 22.05 kilohertz. So long as your signal stays under that limit, all is well. Most of the time, with normal signals, in an everyday mixing scenario, this is perfectly fine. It is possible, however, that when you drive a saturation plugin hard, especially on high frequencies or with aggressive settings and those that push odd harmonics, you'll create upper harmonics above the Nyquist frequency that the system just can't handle, and it will cause aliasing. Aliasing is like when you've seen a wheel turning on a car or a bike and it looks like it's going backwards. And this is the camera. It can't capture the true motion, so it folds it back into these false patterns where it looks like it's going backwards. In audio, when you drive digital saturation without enough resolution, i.e. a high enough sample rate, high-frequency harmonics fold back into the audible range as these nasty, non-musical, metallic-sounding tones. I've got here a piano. Piano covers the most frequencies of the range of human hearing, 20 hertz to 20 kilohertz. So I just want you to hear what aliasing sounds like. This is the piano normal. So if saturation is pushing frequencies above the Nyquist frequency of your session, this is potentially what aliasing sounds like. Okay, I've exaggerated it here because I really want you to hear that so you can recognise it even at very low levels. But that's the sort of mess that can be introduced if you push saturation too far and you get aliasing. So if you look at the spectrum analyzer as well, you'll see those frequencies that have folded back into the audible range of your track. So how can you avoid that happening to you? Simply just use oversampling if your plugin offers it. Or you can work at higher sample rates if your system can handle it. Most modern systems can. So, for example, I always work at 48 kilohertz and I've never had a problem, but don't stress about it. It's mainly a risk when you're really slamming into the input of a saturator for a special effect. So just be aware of it. It's not something that you would typically hear in everyday use. The metallic ringing sounds are a dead giveaway for aliasing, so you should hear it if it happens. But using saturation blindly and just winding in loads of input gain or slapping it onto a really hot sounding track, not knowing that this can happen, is why I wanted to include it in this video, so you don't make that mistake. But there's another hidden problem that can wreck your mix. So you're mixing a song and you're using a saturation effect because you love the way it adds warmth, and Sarah said that saturation is just brilliant, so use it everywhere. But sometimes this effect can do something weird, and it combines sounds together so hard that it creates these odd extra notes or sounds that weren't part of your original music. And it's like mixing two colours together, two colours of paint together, and getting a bunch of unexpected extra colours, most of which will probably be some shade of brown. The plugin doesn't just add those warm musical overtones, which are good, it also accidentally combines your different sounds in a way that creates extra unwanted frequencies. Our ears, thankfully, are really good at noticing these odd sounds, even if they're quiet, and that's intermodulation distortion. When two or more signals hit a saturator together, they interact to create new dissonant frequencies. So let's find the brown equivalent of those two mixed up audio signals. Let's go back to these guitars, which sound like this. Okay, both have got decapitator on. I've set them so that the drive on them is exactly the same, okay? So they are just a copy of one another across these two guitar tracks. So just listen to the quality of that saturation again. There's definitely high frequencies there, crispiness, crunchiness. Okay, so what happens when you combine those signals and send them to a bus and distort the bus instead? Let's listen to that. That's quite different. That crispy, crunchy element has gone, and it just sounds dull and muddy. And this is what intermodulation distortion can do to combine signals. It can just make things sound wrong and alter the tone of your signals in a way that you didn't expect. The problem with this is if you drive the input or go harder into that bus saturator, you can then start to generate dissonant notes that just sound bad. So the likelihood is that you probably won't do that because you would hear that it's wrong way before you ever get to that state. But what I wanted to point out to you there is how, even though the saturators had the same settings, how the quality and tonal aspects of that distortion completely changed once you funneled those two signals through the saturator. So we went from our nice bright colours into that audio representation of brown. So how can you avoid that? Basically, just be gentle with your input gain on mix buses. Use saturation more subtly across multiple stages, like on your individual tracks, rather than hammering the whole group. If you do use it on buses, just, like I say, just be conservative with the input level on those particular plugins. Your ears are the best detector. If something sounds off harmonically, just pull back. So how do you take all of this and actually use saturation to make your mixes more powerful without wrecking them? So think of your mix like a signal travelling through an old analogue studio console. Each stage, the mic preamp, the EQ section, the compressor, the fader, the master fader, and a tape machine adds a little bit of flavour. It's a blend of those small doses that is a wonderful thing. The control, coupled with the tone of saturation, can really elevate your mix. I've got a very simple mix here. Drums, bass, guitar, organ and vocal. Let's work through this and decide what saturation we're going to use where. The drum tracks have all got channel strips across them. Some are adding EQ and some are not. They're just how they default open. So let's just listen to these drums. So it's quite a decent amount, I should say, of high frequency there. What I'd really like from these drums is a bit more thump. So we're thinking here about things like maybe the transformer, maybe tube. Tube, I don't know, might affect the transients a bit too much, dull them off a bit. So I'm going with transformer because you get a nice blend there of odd and even harmonics. Let's try this plugin here from Softtube and let's go with transformer, see what this does to these drums. I'll bypass it and then bring it in. I like that. I heard the thump and I feel as though it's actually smoothing out some of the high frequencies of the transients as well. So let's check this in the context of the mix. Yeah, that's sounding good. What about the other choices we've got here? We've got solid state that tends to produce more of those odd order harmonics. We have our transformer, which is variable and gives us odd and even. Master is to be used on buses, you know, the mix bus or group bus, which could work in this scenario. Then we've got tube and then we've got modern. This is based on an English all-valve design, but leaning towards the use of triodes. So this is all about warmth and punch. So let's just do a quick audition through our choices. So I heard the snare there didn't feel quite as full as it did on the transformer setting. Yeah, and the snap of the snare gets a little bit muted on the tube setting. Yeah, this feels slightly brighter and modern. I'm going to stick with transformer. A great option for the drum bus would also be a tape machine. Tape machines give you, like transformers, that sort of blend of odd and even because there's so many components within a tape machine. You're going to get those odd and even harmonics in a combined way. Plus, you get the extra benefits with tape. With the EQ sections within tape, you can fine-tune your sound. But let's just stick with transformer here for the drums. Sounding good in the mix. What about the bass then? I'm going to go with that Shapes Omni channel, I think. So we've got the pre section switched in. Let's switch it into even and dial in a good amount of saturation on this bass. And let's do it in the context of the mix. I like that. You hear how it brought the warmth and the low end up in that bass. So that sounds really great. Saturation on guitars can really enhance the body of the instrument. These are quite sort of crisp sounding guitars. I've got no EQ on them at the moment. You might think if you brought something that was more heavily leaning towards the odd harmonics, that it's going to bring an aggressive character. That's generally how you think of it, more, something more suitable for rock. This isn't a rock track, and because they're quite crisp sounding, I'd like to make them warmer. So let's try a decapitator. I'm going to go with A being the Ampex preamp, which included tubes. So let's see what that sounds like. That sounds, that's adding a sense of warmth. I always like to use tape on guitars. Let's just add a bit of that as well. And what that's doing is just dulling off that sound a little bit. I think what I'll do is just move it before the decapitator. I like to think that I'm in mixing mode. Therefore, my sounds are coming off a tape machine into the mixing console. So I tend to put tape machines first, but that doesn't mean you always have to. Yeah, let's listen to the second guitar, which is the lead. And I'm going to copy the tape to that. Let's try decapitator on this lead guitar. I'm just, again, looking for a bit more thickness and a little bit more consistency, really. The great thing about saturation is that it has a leveling effect. That soft clipping where you can where it will actually control the peaks of a recording and then actually make it feel louder. It's really great for that, knocking those peaks down but not losing any loudness. Quite a difference there in tone. It's much more crisp sounding now and not quite as hollow sounding. Let's see how these two sound in the mix now. Nice, okay. Organ. Let's listen to this. So I want that to have more distortion, more grit to it. Favourite one for me on this is the actual Thermionic Culture Vulture. And I've got a preset for organ here, which I've nicked from Michael Brower. Let's listen to this. So let's just listen to it in context of the mix. I'll just mute the lead guitar so you can hear the organ more clearly. But it's subtle, but it's just adding excitement. Okay, and so lastly then we've got a vocal. Let's just listen to that in the mix.
I said I think I left the oven on, I gotta go. If my house burns down, I'll be out in the cold.
So I've already got analog emulations here on this vocal. I've got an LA2A, I've got an EQP 1A, both of which are going to be imparting their own unique saturation character. But what about if we were to think of adding a mic pre of some description to this? What about the Neve? Neve sounds great on vocals and on male vocals in particular, to add a bit more of that sort of chest warmth to the tone. And the one I like here is the Lindell 80 series line amp. Let's just try a different section.
The moral to the story must be told. Time is tight, we all get old. You just don't have to buy what you're being sold.
It's really very subtle indeed. To me, it just feels a bit wider, a bit thicker, taking up a bit more space in the middle of the mix. Let's listen to that section in the whole mix.
The moral to the story must be told. Time is tight, we all get old. You just don't have to buy what you're being sold.
Strange noise. It does sound thicker. Definitely sounds thicker to me. And it's more perceptible sounding thicker in the mix than it is in solo. That could be just me. So let me know in the comments if you agree. Let's try a tape machine on the mix bus. What I'm looking for is a gluing effect, really. I just want the tape machine to just smoothen things out, maybe enhance the signal a little bit with a bit more thickness, and then maybe a little bit more punch or clarity at the top end. Let's try Kramer tape, bypass it and bring it in.
I said I think I left the oven on, I gotta go. If my house burns down, I'll be out in the cold.
And for me, what that's doing is it's tucking the vocal in really nicely into the instrumentation and just making it feel more like a finished sound. I'll start with it in and then I'll bypass it so you can hear the difference.
I said I think I left the oven on, I gotta go. If my house burns down, I'll be out in the cold. Maybe we can meet again now, you never know.
It's just tucking everything in. Some sort of resonant frequencies are being controlled as well there on the vocal. It feels warmer on the bass guitar and on the drums. So that is a great use of a tape machine on a mix bus. So with all those extra levels of saturation, let's try and do an A-B between the before and the after.
I said I think I left the oven on, I gotta go. If my house burns down, I'll be out in the cold.
So how can you apply all this to your mixes? First of all, it's about adding small amounts of saturation at multiple stages. Then you want to match the saturation type to the job. and always gain stage for clarity. But keep a mental sweet spot in mind. Enough harmonics for life and texture, but not so much that transients vanish or the mix turns to mush. Saturation is like seasoning. Once you understand the flavours, the heat level and the chemistry, you can transform your mix without overpowering it. Your channel strip plugin is another saturator, and each one adds its own tone. Some bring warmth, others add bite. And choosing the wrong one is like adding barbecue sauce to your fish and chips instead of salt and vinegar. Watch this video next that compares the most popular options so you can pick the one that complements your mix on purpose and not guesswork. That's all from me. Thanks for watching, and I'll see you in the next video.